Well, thanks a lot for the introduction and also for the invitation generally. I'm really honored to be speaking here at the first COLM conference. It really feels like something is getting started, and I'm really happy to be here and very honored as well. And thanks also for coming to this morning session to all of you. So yesterday, I think it was Yoav Artzi who described the COLM conference as being both narrow and broad, right? And I really like this kind of way of describing the conference because it's true, it's narrow in the sense that there is a focus on language models, but also broad because there are so many fields that can be interested in this technology and where things can be done with language models. And I think that this cross-disciplinary perspective is something that I really like and that I feel very comfortable with, right? And yeah, so it's true that language models are being used in all sorts of fields, like not only fields that are powered by machine learning, like robotics and obviously automated reasoning and other kinds of fields, but also within the humanities and the social sciences and media studies, etc. Right? For example, I have a colleague, Roberto Cerina, who is a social scientist, who is now using language models for his research on political opinion. And I'm sure that many of you have other examples around you of how this technology has led to new research directions by people that belong to different fields, right? And I think that maybe at least within the humanities, social sciences, etc., what has made it easier is that it's very accessible to just prompt a language model in natural language and then get a response that is very naturally sounding in natural language as well, right? And this makes it very accessible and very easy. And indeed, obviously, we all agree that language models are exceptionally good at producing fluent, grammatically correct, apparently also meaningful language. So to use the terminology in a paper that was also mentioned yesterday by Chris Manning, by the way, by Kyle Mahovald and Anya Ivanova, coming from the Fedorenko lab, right? To use the terminology of formal language competence, so where language models are very good at least, is this formal language competence of producing this extremely good sounding text that is grammatical, like really mastering syntax, morphology, etc., and to some extent semantics that also looks coherent, at least at the surface level, and often very undistinguishable from actual human text. So I think that there are no controversies here, right? But still, I would say that the question arises of whether language models are good at using language, right? And perhaps the authors of this paper, and F can correct me later if I'm wrong, would argue that maybe we should just not expect them to be good at using language, because that's not what they have been trained for, and that's not necessarily the case, at least if we take inspiration from how the human brain is organized. So that's a possible way to go. But to be completely honest, I'm not sure that I fully agree with this view of what's the core of language. It's something that we could discuss at length, right? But I would say that what's most worth studying from a very personal perspective is actually language use, and that at its core, at its most important factor, language is basically something that is for communication, that is for interacting, that is for coordinating, that allows us to get things done together, right? So language use is a form of joint action, and that's what I find most exciting. Of course, there is no one better than Herb Clark to argue for this point, right? And here there is a quote that has been used many times over the history of talks, right? Where Herb says, the common misconception is that language has to do with words and what they mean. Well, it doesn't. It has primarily to do with people and what they mean, right? So what matters the most for actually being able to use language effectively is figuring out what's the speaker meaning, right? So what are the speaker intentions, what we aim to do with language, and not just understanding what the words are about or producing language with good grammatical structures, etc., right? So the core is about understanding what speakers mean. We can call this a speech acts and so on. And this is something that is really constructed within interaction. In this nice paper, Clark and Shover give these examples of an utterance like, for example, "to please." So this little utterance that is very underspecified actually acquires its meaning very easily if we are in the right situation, right? It can mean many different things depending on the game that we are playing, what language game we are playing, what we are doing at the moment. If we are at the cinema ticket window, this could mean 2 tickets for Barbie, for example. Or if we just enter an elevator, this could mean push the button to the 2nd floor, right? And typically, the meaning that we arise will be constructed online on the spot by the participants. But very importantly, even if we don't manage to construct this meaning by relying on the information we share, by relying on the common ground, which often happens, if we still don't manage, very importantly, we have conversational grounding strategies, so ways just to solve any undesirable under a specification by asking clarification questions, by having different means that allow us to stay in sync with what we think the conversation is about and what we think that we are trying to achieve, right? So this idea that we construct meaning in interaction and that we monitor and build our common ground by using conversational strategies is fundamental to language, right? So we have strategies that allow us to stay in sync. By asking, by interacting, by acknowledging that we are actually staying in sync. And as I was saying, so I find this perspective, this is basically the perspective that calls to me the most. Of course, there can be different opinions on what's worth studying about language, and probably many things are worth studying, but I particularly like this kind of perspective. So now here's the roadmap of what I would like to discuss today. First, I would like to mention briefly a few ideas about language models' potential for conversational grounding. And then I will move into visually grounded models, into multimodal grounding models, to explore a little bit what is it that we might gain by having multimodal grounding. And as we will see, this is not going to get us very far when it comes to conversational grounding. And at the end, if I still have time, then I would like to mention some recent work that we have been doing on multimodality in face-to-face communication. And apologies if my voice and that is being too low, then just wave at me or something. I'm trying to exploit the mic as much as possible by keeping my voice low. All right, so one way to think about speech acts is as something that kind of constrains the set of what are possible follow-ups within a discourse, right? So this is a very classic way to think about the speech act. So to comprehend a speech act, to get at what's the intention behind a given utterance, is to have certain expectations about what can come next in a dialogue or in a discourse, right? So for example, take this little dialogue here. Can you help me, please? Sure, if I can. I want to send this small parcel to Canada. At this point, there are many things that could come up, but not everything could come up. But there is certainly a set of possible continuations of possible actions that could be relevant. So these are some possibilities here. We may want to ask for some follow-up information or other types of things, like clarification questions or follow-up information, or just act on what seems to be a request here, right? So there is a set of possibilities. Now, the variety and also the number of plausible next actions is not always the same. That depends a little bit on what's the language game that we are playing, right? So what's the communicative task? So typically in a dialogue, depending on the context, of course, this set is quite open-ended. Many things can happen in a dialogue at any point, right? In other types of language games, in other types of tasks, of NLP tasks, then this may be a bit different. For example, if we are playing the translation game, right? If we are just translating from one language to the other, then the kind of action that comes next is quite restricted, right? It's a translation, let's say from English to German, right? But still, there can be quite some variation then at the surface level of how we may express that next action, which is the translation, right? So, for example, a phrase like several companies can be translated in different ways in German, right? So we find variation both at the level of the kind of next action and also about how this next action might be realized in practice in surface form. right? So we had a study last year that was led by Mario and by Joris, also together with Barbara Plank, who's here, and Wilker Assis, where we looked a little bit at these aspects, but from a slightly different perspective, not exactly the perspective of speech acts, but I think this is still relevant, right? Where we looked at the generation potential of language models and how this compares to the variability that we see in human generations, in human productions, right? And the perspective of this paper goes more or less like this. So we can think of a language model having as its core basically a probability distribution of a word sequences given a prompt or given a context, right? So this is at the core of the language model. Possibly the language model is more than this, but at its core, it's this kind of language generator, a probability distribution of a sequences of words. And this can also be conceived as a representation of the uncertainty of this model, right? So in this paper, we are asking, is this representation of uncertainty that the model latently has in compliance with human production variability, with the variability that we see in human productions given the same type of context, right? And we devised a framework for probing for this, for investigating whether there is, whether the fit is reasonably good or not. So let me just give you a bit of a gist of what this consists in. So we cannot directly compare the distributions of the population of humans and of the language model itself, but of course we can sample from these processes. So we can sample a few productions given a context from a language model and also from a human population. Obviously for this you need data sets that do have several human continuations for a context, which is not something always easy to achieve, but we did gather a few data sets, existing data sets for this work. And so we can sample a set of productions from the language model, from the human population, and then we can just compute the variability within this set of productions, within this set of generations, using different types of measures. In the paper, we define a few simple measures. For example, one could be cosine distance between the sentence embeddings of these productions to approximate something like semantic variability or whatever is in these embeddings, probably something a bit mixed, right? And then once we have computed variability in this way, then we can measure deviation from human variability by using a statistical divergence between the variability we see in the human data and the variability we see in the generations from a language model. So to just give you a glimpse of the kind of empirical results that we get in this paper, here on the left, you see the variability that we observed in humans for different types of tasks. So we are dealing here with 4 tasks: dialogue and translation, as I showed you before, but also text simplification and story generation. And you see very nicely, I think, in the left, how depending on the language game, as I like to call it here, depending on the task, the variability is very different. So we have more open-ended tasks like dialogue or story generation, where there is a lot of variability on the next continuations, and other tasks like translation or text simplification, where this is much more narrow, right? So this is clearly divided. Then on the right, you see the level of divergence in this variability that we observe in the model generations when we sample from the model. Right? And so if this is aligned to 0, then it means that there is no divergence, and otherwise there is an overestimation or underestimation of the variability that we see in human data. And basically, I think, yeah, so there are, of course, more results in the paper, but basically what we can see here is that in some cases, the language model overestimates variability. For example, actually in the more open-ended tasks like dialogue, this is at the bottom here in red, if you can see my mouse, yeah, right? And in some cases, like in translation, it actually underestimates the variability. So it turns out that in more closed tasks, it underestimates variability. In more open-ended tasks, it actually overestimates it. But overall, I would say that the fit maybe is reasonably good, right? So, right. So yeah, so to some extent this variability is captured, but not always perfectly. And I think there can be some interesting things on investigating the patterns of when this doesn't, why and when this doesn't work. Now, let me just make a side note. If you are interested in psycholinguistics, in computational psycholinguistics work, I just would like to point you to these papers led by Mario. This is just great work by Mario, together with Saren as a collaborator, and Ryan Cotterell as well in one of these papers, where we are using this idea of sampling from a language model to propose a model of processing difficulty that ends up having very strong predictive power for different psychometric responses, right? So if you're interested in this line of research, I suggest that you take a look at these things. Now, to go back to my argument, so maybe we are reasonably all right when matching the level of variability that we see in the possible continuations that the language model is entertaining, right, in this kind of generation potential that the language model sees. Now, can we conclude from this that the model really infers communicative intent? Well, I didn't define very well exactly what it means to infer communicative intent. But I would say that no, right, probably we cannot conclude this. That might be a good starting point, like maybe a necessary condition, but obviously not a sufficient one, because that probably means many more things. And still, this somehow to me seems connected to some takes that have appeared in the literature. One of them, a paper by Jacob Andreas, I don't know if he's here today, but that you may have come across from a couple of years ago. It's a kind of position paper where Jacob kind of argues that language models seem to simulate agent behavior to some extent, right? That through the next word prediction task with which they are trained, that they may infer some sort of maybe partial and so on representations of the intentions of the agent that is producing that context, right? That is producing the prompt, okay? So because we see the language model sort of reacting coherently very often, so maybe this means that to some extent, some kind of partial representation of the intent is actually being captured, and that, okay, this could be a good starting point for language use, in fact, perhaps beyond this formal competence that we were talking at the beginning, right? So this paper, was published, more than 2 years ago. Well, no, around 2 years ago, I guess, right? And so since then, I would say that mechanisms like instruction fine-tuning, RLHF, also DPO, etc., have become more mainstream than they were at the time. Some of them were already present, but now they really have become much more mainstream. And this really makes me wonder what change this has made, right? Because because these methods of training do have a bit more of an interaction flavor, right? There are a little bit more interaction. We are trained on instructions. These are 2 turns, etc. We are asked to provide preferences for responses to another turn. So this is really a bit going beyond just next word prediction, right? And I really wonder what's the effect of this. I have to say that I haven't been able to get my head around of what kind of more formal object we get when we apply these techniques, right? So it's very clear that we have a probability distribution over sequences before. Now what we have, I don't know, and I was happy also to see that there are some papers at the conference who are really trying to get a bit more insight on what are these techniques giving us, right? We just see that they are giving models that kind of perform well on different things, but exactly what we get, it's difficult to get my head around it, and I'm not going to give you an answer to what we get here. But basically, I was wondering whether this could be a bit leading us to more kind of interaction-related models that perhaps are also more able to use conversational grounding strategies, right? More interactive strategies for not only inferring directly the intentions of the speakers, but monitoring this common ground in a more interactive way. Well, it turns out that this is not quite the case, at least so far with our current setups, right? So, as I've been saying, while humans use a range of conversational mechanisms to build common ground, such as acknowledging, clarifying, to avoid misunderstanding, and so on, instruction-following language models are trained to directly act on a command, right? So it's very unlikely that the model will just keep on asking questions, for example. So they have a kind of bias towards assuming that there is grounding, that we are on the same page with the user and just providing an answer to the question. So this kind of argument was made very convincingly, I think, by a recent paper coming from Stanford. If you haven't seen this paper, I really recommend it. This is a lovely paper, one of the papers that I've enjoyed the most this year. And basically, in this paper, the authors are comparing the amount of conversational grounding that we see in human conversations in different types of setups, like, for example, counseling and others where sorts of misunderstandings can be really very important, and the amount of grounding that we see in language models. And the conclusion is very, it's very clear. So language models use significantly fewer grounding arcs than humans. So the conversational grounding behavior really is very different, and there is this tendency to assume grounding rather than build it during conversation, right? And so the paper, as I said, is really interesting and really nice, and they also test whether some forms of instruction supervised fine-tuning and DPO may actually help depending on the data that you have in this kind of data set and so on. And the conclusion from the experiments that they run on the paper is that this actually, with current data sets, that this does not help at all. If anything, like continuing fine-tuning with DPO, for example, will reduce the level of grounding. So we are not really solving things, right? So this is, so far at least with the kind of techniques that we are exploiting, we are not moving towards language models that are more language users in the sense of conversational grounding, right? Okay, fair enough. That means that we have a lot of things to do. So what is it that we are missing? I'm not sure exactly what we're missing. But one possible question that we could ask is like, well, I don't know, maybe our semantics is just not rich enough, right? Because we just don't actually have enough good representations of meaning, and therefore, how can we expect that we even check on whether we are on the same page on what we are saying, etc., right? So one possibility would be, okay, so I don't know, maybe let's try to do visual grounding. I'm mentioning here this kind of quote by Jan LeCun and so on. Yesterday, Chris already showed you that clip that was making fun of Jan LeCun. I don't want to go deeper into making fun of him. But many people, not only Jan LeCun, of course, have argued that, well, maybe we just need something else. Text is just not the way in which we learn language, right? And I mean, it's true that definitely we learn language in combination with many other different modalities, right? So we use language in combination with vision, also with hearing, with touch, with action, and so on, and we learn it in this way. Right? Even if we are impaired with respect to some of these senses, usually we will still have multimodality coming from different senses. And indeed, there are quite a lot of cognitive evidence and neurological and cognitive evidence showing that a good part of our conceptual knowledge that we connect to language is actually grounded in our sensory motor experience, right? So that's there, and we may want to just learn models that exploit this information, right? Besides the fact that there are a lot of cool multimodal applications that we want to tackle. Okay, so yeah, some multimodality could be a way of enhancing our models in some way, maybe not very directly connecting to conversational grounding, but who knows, let's see, maybe it can give us something. So do we have information about whether, what do we know about whether visual grounding actually helps us, like kind of give us an advantage over only learning from text, right? So at least, for example, in terms of language learning, just an example of some things that we know. So something that we do know is that it appears that visually grounded models do learn richer representations of words, so that at the lexical level, having visual information, some sort of visual supervision, does give us richer representations of words, richer in the sense that they are more aligned with human representations, with human conceptual representations. This is a study that we did a couple of years ago with the vision and language models that were available at the time. And that actually echoes results from previous studies done in like pre-transformer distributional semantics, like visually grounded distributional semantics, right? So it does give us an advantage for some words at the level of lexical semantics, at least for some words, like for concrete words. So actually, here are some of the results that we obtain in this paper. So we are here checking the correlation between the cosine similarity of the model representations of certain words and semantic similarity judgments made by humans, right? So this is how we evaluate the models. And we can see that in data sets of human semantic similarity where the words tend to be rather concrete, so things like donut or bike, these are kind of highly concrete words, then the models that are supervised with visual information definitely do better. They correlate better with the human judgments. However, when the words are more abstract, say freedom, dreams, etc., then language-only models, BERT at the time, actually do better. So visual grounding does help, doesn't mean that it always has to help, right? So sometimes it might be far less relevant, but sometimes it does lead to richer representations that are more similar to the conceptual knowledge that we humans have. Another facet where it looks like it helps is at the language learning. That's another paper, but the recent one by Jacob Andreas and also Fedorenko, right? Where a very interesting paper as well, right? Where that shows that, yeah, again, multimodality maybe is not critical in some situations, but it does help when we are learning word meanings, particularly if we have more limited data. Right? So it can help in terms of efficiency. So in a way that kind of mirrors a little bit human acquisition, okay? So yeah, so it does help sometimes. And yet we should not conclude that these models kind of represent things in ways that are very human-like or so, right? So there is quite some potential on these models, but sometimes there are also some results that can be a bit puzzling. So, for example, this is another study that we did recently led by Eche Takmas, where we see that vision and language models lack biases about what makes visual stimuli difficult for humans. Right? So you can get at this difficulty of processing, for example, by looking at eye tracking data when people are describing images, by looking at the scan paths of how people scan the images, also by looking at the variation in the scan paths across participants, and also, for example, by checking how long it takes people to get started when describing an image. All these are indications of how effortful this is. And since this effort, partially at least, should come from properties of the image, of the stimulus, you can wonder whether these properties of the stimulus are actually captured by vision and language models that are learning from these images, right? So it could be that they are captured. Well, they are not very well captured, right? So when we probe the models to see whether this information is somehow encoded in the representations, the results that we get are really not very strong. So these biases are not quite there. So at the beginning, I was talking about lexical semantics, like word knowledge and word learning. The previous work that I mentioned has to do already with full image descriptions. And indeed, when we look at more compositional, like cross-modal interaction compositionally, like building more representations of situations, not just of words, this is quite tricky. And yes, so many visually grounded models actually do have problems with these compositional aspects, particularly models like CLIP that I just trained contrastively to align textual descriptions with images, right? So it is well known that it appears that they tend to learn more back of words type of representations of how text is aligned with images and not so fine-grained, right? So, for example, we tested this with very simple sentences. So constructions like active, passive alternation and other types of alternation that are also present in the paper. And this is a kind of adversarial data set, right, where the goal is to ask the model whether it can distinguish which of these sentences are true or false of the images, right? These sentences basically contain the same words, but they are constructed in such a way that only 2 of them are true and 2 of them are false. Well, it turns out that basically models like CLIP are at chance level on this, right? So the compositional understanding can be really very poor, and as I said, these are very, very easy type of constructions that preschoolers already are able to comprehend, okay? At the time, in the last couple of years, quite a few benchmarks testing these kind of things appear that are quite similar. You might be familiar perhaps with the Vinoground benchmark that also looks at compositionality in this way. Already in 2021, there was the SVO probes benchmark by Eitan Ematzadeh and colleagues where they focused on verbs. And there are quite a few papers that developed this kind of baselines, and it was quite striking to see how badly the models were doing in things that you would expect that they reflect well, right? So still, you see like the kind of representation and alignment between the modalities that these models are able to achieve can be sometimes strikingly poor. Yeah, just to mention another example, more recent. So we also see that, for example, on the task of understanding what's the message behind an advertisement, a visual advertisement, also contrastive models can be easily fooled by explanations that are just very grounded, right? I hope that you can read the examples here. So if you just propose some adversarial examples of explanations that really mention entities that are present in the image, or even mirror text that is present in the image in this advertisement here, then the models will just think that that's the right explanation, even if it is more implausible from a common sense point of view. Okay? So quite some weaknesses when it comes to models. Still, I don't deny that they are also able to do quite impressive things, but when you poke a little bit deeper, then they do have important weaknesses. Okay, now all the work that I have mentioned up to now concerns vision and language models that are not the latest generation of models that are putting together generative LLMs, right? So models like Lava, Orthidefix, and so on. And I should say that a lot of these problems are somewhat fixed by having a powerful generative LLM put into the mixture, right? So a lot of the compositional aspects have improved a lot, right? So this is really just in the last year or so, right? And still some issues remain though, but there is definitely improvement. But even though there is improvement on compositionality, on compositional understanding, there are still many other things that are very important and that we should figure out what role they play, right? Like, for example, what about ambiguity, right? So when there is some under-specification of what's happening, and now I'm moving more into the conversational grounding realm again, right? So ambiguity and under-specification are really everywhere in language. You here have some example of a very under-specified utterance with pronouns, etc., like put the flowers there and so on. And very often we are just able to resolve this under-specification by just building on our contextual information, right? But as I was saying at the beginning, if we cannot resolve it, then typically we should resort to conversational grounding strategies by resolving the uncertainty by using these conversational grounding strategies, right? So that's also why I think that ambiguity is an interesting case study, because it also allows us to test to what extent the models will just assume grounding when there is ambiguity or actually be a bit more proactive, particularly now that we have these generative vision and language models that are powered also by instruction following. So, for example, we can consider referential ambiguity in the visual domain. So this would be visual situations where we have more than one entity that can be the referent of a certain referential expression, right? So like, well, you can see here, so if I tell you, give my greetings to the professor, so there are two persons here who could be the referent, or in the question, what color is the trash bin? In this case, there are two possible referents, right? And even though this kind of utterances may sound a bit weird, actually they could arise in an interaction for several reasons. For example, the participants may have unequal access to the visual context. So in fact, this image here was taken by a visually impaired person that was asking a question of this kind. So this can happen. Or there might be also mismatches in the dialogue history that give rise to this kind of questions that seem to come a little bit out of the blue, right? And so if we don't recognize this ambiguity and just answer the question, well, this can have serious consequences, of course, because we just may have a misunderstanding if we are not aligned on what we think is being referred to. And sometimes, like in the situation here of the professor, having a certain assumption could lead to just stereotypical behaviors, possibly. So in order to analyze this kind of aspects, so we started a project that is led by Alberto Testoni, also with Barbara, and where we are asking to what extent multimodal language models how do multimodal language models respond to this kind of ambiguous question, and to what extent they make assumptions that are unwarranted. So I'm just going to give you the gist of this. This is not yet published, but soon I think we're going to put it on archive. So I was excited about this, and I just wanted to give you a little bit of an idea. I will just skip over many methodological aspects, which are in fact very interesting, but just to give you a summary of where we are at the moment. So to investigate this question, we've created a data set with two different settings. The first setting is one where we have images from the MS COCO data set, where there can be referential ambiguity because we have several entities that are of the same type, none of them being too salient, etc. And we are pairing them with handcrafted ambiguous questions, like, for example, the ones that you see here: what color is the vase? What does the sign say? Etc. Okay. This is the first setup, and then we have a second setup where we are generating images that represent people, and also and also pairing them with handcrafted ambiguous questions. These are a little bit different, right? So we have the generally ambiguous question, what is the person wearing? But here we insert an adjective that in principle cannot immediately be visually grounded, things like assertive or sweet, right? And that if it happens to be used to disambiguate in this context, then it could reflect some stereotypical assumptions, right? So the choice of these adjectives is all well motivated by existing research on stereotypes, etc. And we are generating the images here because we really want to control for different dimensions. So we want the difference between the individuals in the image to be only one dimension, for example, gender, or for example, race, or for example, disability status. These are the dimensions that we are looking into. So that's the reason for using generated images. So how should one react, what are the possible reactions that we can have to these kind of questions? Questions like, what color is the trash bin here? Right? So there are, a priori, there are several possibilities, right? So one possibility is, well, this question is ambiguous. I'm not sure there is enough information to make an assumption, so therefore maybe a natural thing to do would be to signal the ambiguity, to actually try to build common ground without assuming it to start with, right? So by doing this, we could, for example, mention that there are actually different entities here, or just asking a question like, which one do you mean, right? Possibly, we could also just assume that there is an intended referent, right? And we might just respond by indicating which one we thought that it was intended. Like, for example, the bin on the left is black. If you were asking me what color is the bin on the left is black, right? And like this, we are providing a bit of information. So we are saying, well, this is the one I'm assuming. Therefore, our interlocutor could potentially correct us in the next turn if we are wrong. So we are giving some opportunities for grounding, after all. Or we could just assume an intended referent. So what color is the bin? Green. We are just assuming an intended referent and not doing anything else. So after all, we are using the questioner used a definite article, the trash bin. So there is a kind of presupposition of uniqueness. So our interlocutor must be assuming there is one. I'm going to go with one, and that's it. So there are some possible ways in which we could respond to these questions, right? So how do humans actually do respond when we present them with these kind of questions? So we had a small study. This involves only 4 participants. Quite a bunch of questions, I don't recall the number that, and this is the distribution that we find in the questions. So overwhelmingly, people do not immediately assume that a certain reference is being produced, right? So they do either point out the ambiguity by listing the different possibilities, like in this case here, or they just ask a clarification question. What's he wearing? Which of the 2 guys in the picture? Right? So that's how humans will most of the time react. Sometimes they also use the other strategies that I mentioned. For example, in this case, what color is the car? The closest one is black. Okay, so I'm telling you which one I think you mean. Or even sometimes, but also again very seldom, they may just commit to a certain interpretation that they think the speaker, the questioner is intending, right? What color is the traffic light? In this case, one of our participants responding, it is red. for whatever reasons. But in any case, we can clearly see that humans do prefer to point out the ambiguity without making pre-assumptions. So how do models respond when faced with the same type of questions and the same type of stimuli? So we are testing here a bunch of open models. These are, again, instruction following fine-tuned vision and language models, and also a few of the proprietary closed models. Right? And you can see already immediately the difference in the distribution. Right? The human distribution that I showed you before is here at the bottom, and you can see that most of the times, for all models, most of the times they don't actually point out the ambiguity or use any kind of conversational grounding strategy. So in fact, in all the green parts here, they never ask any clarification question. So what happens is that they would just describe the image by listing the different options, which happens more often with the proprietary models. So basically, unlike humans, models overwhelmingly make assumptions about a single intended referent, and if they don't make these assumptions, then they never actually ask clarification questions. Here's an example of some responses. So in this case, like more appropriate responses by the proprietary models, where the different possible references are listed, and then here are some examples of how the open models in this case perform a little less appropriately, right? So, for example, sometimes just making a direct assumption, the bus is blue, or the bus in the image is blue, the bus in the foreground is red. Not clear what's the bus in the foreground exactly, perhaps this one, I'm not sure. Right? Methodologically, I should point out that the way in which we classify these responses by the models is by using the Llama 7B with a very long prompt to recognize these responses, where we have seen that there is a very strong human correlation with this classification. So it seems granted to use this method. Now, so the fact that the models don't ask clarification questions, that's probably a consequence of instruction fine-tuning, as I said before, right? So they assume grounding, the way in which they have been trained does not prefer to use clarification questions. So we can try, so they don't use clarification questions, we can try to go a little bit deeper into what are the model's abilities of recognizing ambiguity by using some prompting techniques, right? So for example, we can include in the prompt things like, let me know if you need further information to answer the question, right? Or please make sure that you seek further information if you need it, etc. So we can add this we can intervene in this way by using prompts. And you can see that at least with GPT-4o, this leads to a higher percentage of responses where the ambiguity is acknowledged, but still way below the human rates. Okay, so a little bit of improvement in pointing out ambiguity, but it's not a solution, clearly. Some examples, like for example in this case, if we don't use the prompt intervention, then GPT-4o just says the backpack is blue. These are about the backpacks from here that people are wearing. If we use the prompt intervention, then in this case it does mention different types of backpacks. So that makes a difference. Here actually it does ask a clarification question. So from committing to a particular referent and so on, and pointing out which one with this prompt intervention, then we go to a response where the ambiguity is being pointed out and where a clarification question is asked. Could you please specify which person you are asking about? But again, these are mostly exceptions. Most of the times this does not happen, right? We can also try chain of thought, of course, and again, it is interesting what happens here. So this is the response by the model if just the raw question is being asked, so the airplane's tail is blue, possibly this one. If we actually ask, please explain your reasoning step by step before providing a final answer, then we see that sometimes this ambiguity is really being pointed out in the steps. So it's meaningful, but often the final answer still commits to a particular referent, right? With an explanation of why that referent was chosen. Note also that, for instance, a different referent is chosen here than it was chosen here, and there is no reason why one would be preferred over the other one, right? We could argue about this, but in principle there is no reason. So this does lead to some kind of recognition, acknowledging of ambiguity, but still I would say that this also does not solve things. Just another example, maybe we don't have to go through it. So this is an example where this does not work. Basically, the answers are wrong, the reasoning is not quite working. Just in the interest of time, I will move on. If you cannot read the example, hopefully you'll have the slides later. Let me tell you a little bit about the second setup, where we are focusing more on images that depict this kind of social groups, right? So the generated images with people from different social groups. What happens here? What do the models do? Well, first let's see what they do when they just are faced with the general ambiguous question, what is the person wearing, right? And so in this case, GPT-4o, for example, does recognize the ambiguity most of the time. It will ask, well, which person, or it will not ask which person, sorry, most likely it will just say there are two people in this image. One is wearing that, the other one is wearing this. Much less so for lava. But when we do insert these adjectives that are stereotypically associated with one of the individuals in the question, then we see a complete change in the picture. So most of the time, GPT-4o will choose the bias interpretation, right? So for example, if we use switch, the bias interpretation in the gender dimension would be to choose the female person here, and very similar rates of choosing the bias interpretation between the closed models and the open models in this case, right? So yeah, there is clear bias for the social stereotype here. So basically, with vision and language models, I would conclude from this that there is no grounding behavior, and there is just assuming a certain interpretation of what the intention is without going any further, and this often this could lead to stereotypical behavior besides just not getting rid of misunderstandings, right? So a side note as well, if you're interested in stereotypes and in social biases, then tomorrow in the poster session, you can take a look at this paper that Vera will present as a poster, where we are looking at similar type of stereotypes, as I mentioned, in this work on visual grounding. And this is also work in collaboration with Ariana Bisazza, so please take a look. All right. So I've talked a little bit about conversational grounding, a little bit about multimodal grounding, and how this interacts with conversational grounding. Altogether, maybe the news are not so great. I wanted to finish by just saying a few words, if I still have a couple of minutes, I'm not sure, yes. All right. On some recent work on multimodality in face-to-face communication, which I also find very interesting, right? So, in fact, the primary form of language is just, again, to quote almost Clark, is actually face-to-face dialogue, when we use dialogue in face-to-face communication when we are seeing each other, right? So when we talk about multimodality in these setups, this is not only about visual grounding, like symbol grounding and so on. Multimodality actually here refers to the rich array of signals that we are exploiting in this setup, where we just merge speech, language with gestures, with gaze, with facial expressions, and so on, right? So this is, again, very much part of what language is, right? So typically we will learn language in this kind of face communication, so all these aspects are being integrated together. And very often we're just neglecting this because in the NLP community, machine learning community, and so on, most often this setup is just on the margins of what we are working on, right? So we've been doing some work on these setups. I'm really very excited about this, focusing on gestures and trying to learn representations of iconic speech gestures. So these are gestures that are happening in conversation that typically we would use to refer to objects, right? As opposed to other type of gestures, like, for example, emblems that would be something like this, or beat gestures that would be a bit different, right? So here we are trying to learn gesture representations, and because these are co-speech gestures that happen at the same time of speech, then actually the use of language models can be very relevant, right? So now we have these powerful tools that we can use for these setups as well. So in this case, we are applying this to referential task, where you have two people interacting and they have to refer to different objects. And we want to build robust representations of these gestures. So just to give you a brief idea of the kind of modeling that we are using two backbone models. So one model that would be a gesture encoder, where we are using a model that has been pre-trained for sign language recognition, and on the speech side, a speech language model, pre-trained speech language model as well, a wave-to-back model, right? So we take the two sources of information and encode them with this pre-trained model. And then we use contrastive learning, so a bunch of different types of contrastive objectives to align the sources of information, right? So we also use augmented views on the gesture side. And then, yeah, so a bunch of different contrastive objectives to try to align text and speech. And yeah, so this gives us some gesture representations that are actually quite interesting for our colleagues in cognitive science, right, that usually spend a lot of time actually annotating these things manually, right? So this really gives us tools for having data-driven representations of gestures that then we can use to actually analyze gesture patterns, or also to power other downstream applications. So I think that there is quite a lot of potential for the things that can be done here. And in the paper, there are some interesting empirical results about how people coordinate gestures when they're interacting in conversation. So take a look as well. All right, summing up, if I can spend 1 minute. Yeah, so basically, I've tried to convey to you that language use is all about exploiting and building common ground, or that this is the facet of language that I find most interesting. That responding overconfidently, committing to a certain interpretation, as often our models do, goes against the standard conversational groundings that we see in people, and that we should, I think it's worth to try to work towards improving this, right? And there are many open questions that I hope to maybe discuss with you, if not in the question time, then later, right? So how should instruction or preference learning be adapted to actually achieve this goal? Right? So how can we adapt this? Should we go for more multi-turn type of interaction, just instead of just having a single turn type of learning, right? Or should we go for something else entirely, something that is more multimodal and so on? And of course, people that have worked on maybe in theory of mind approaches go more for the modularity approach. So there are several options here, but I think that there are many interesting open questions, right? Yeah, I'm just running out of time, I suppose, just mentioning the main things. So we've also seen that visual grounding by itself is not particularly helping with conversational grounding, even though sometimes having situated scenarios can help us to make progress in diagnosing what's the level of conversational grounding. Plus, cross-modal interaction is just really interesting. And yeah, I just want to say that, you know, all these aspects have been studied for a long time, but I would say that now we have actually better tools that put us in a better place to actually make progress on these aspects, right? So I think it's interesting to look at them with new eyes, given the powerful tools that we have at the moment. Just finishing by pointing out some related work. There is plenty of related work to this that I haven't mentioned at all, just to point out to a couple of papers by some of my collaborators, which I find very interesting. There are many more that I'm not pointing out here. And also just to point out to 2 papers at the conference that are coming up in the poster session now that do take this more interaction-based perspective and that look very interesting, and I'm looking forward to go to the posters and talk more to the authors. So it's nice to see that this line of research is also being explored to some extent, maybe not enough as I would like it to be explored. I want to end by thanking, well, again, the organizers for the invitation, also all the members of my research group for the awesome work that they do and how fun it is to work with them, and all of you for your attention. Thanks.
So we have time for questions, maybe 2 or 3 questions. You can use the microphone.
Thank you for the really thought-provoking talk. I really like the idea on whether and when a model should ask for clarification. Like, I thought you gave a really nice motivating example with the potential ambiguity where there's some bias where if you make an assumption, you're going to make the wrong assumption. The other earlier ones, like the bus example, I thought the model's responses seem pretty fine. I'm actually okay with it over-explaining in a way that would be weird if a human did it. And I was wondering if you thought that the move towards models that take actions on our behalf, like agent-based models, might force the models to actually engage in more grounding, because if they make a mistake in assuming what you want, it actually has some significant consequences.
Right, thanks for the question. So, yeah, so okay, just a comment on this other answer. So yeah, I think that what is a reasonable answer to an ambiguous question is quite tricky and very much context dependent, and also it depends on the assumptions that we make on, like I said before, on whether the questioner also has access to the visual information or not, right? So sometimes just describing the possibilities may assume that maybe there is no access to the visual context, so that can make sense, right? So I think that, yeah, what's appropriate is an empirical question, and we try to respond to this to some extent by checking what's the distribution of questions, of answers that we see in humans. Now, as for your comment on agent-based models, yes, so I think that, of course, in agent-based type of models, then staying on track is part of it, right? So it's really what we need and what we want. Whether these models really are able to keep track of the state of the conversation appropriately and act accordingly if that's not the case, in the sense of checking and so on, I think that this is still an open question. I haven't seen very convincing examples that this is happening, but that's a facet of research that is very relevant to this, definitely. Thanks.
Hi, I'm Adina Williams. Hi, Raquel. Super cool stuff. A lot of this is, yeah, very inspiring. Excited to read the papers that you're going to share, particularly the referentiality one. I was kind of interested in what you think the failure comes from in those examples. Let's say the example where you have what color is the bus and there's two buses, or what color is the plane's tail. Because I feel like there might be kind of two failure modes, and I was wondering if you had impressions on which ones, or maybe both, are at play. One is that the visual salience is actually different, and so one of those planes or one of those buses would also strike people as more visually salient, and if you really press them to respond, I'd wonder if they picked the same color or the same object as the model. The other one is maybe something about the uniqueness presupposition of the definite article, which gives you sort of a number inference, and a lot of models, language models, but also probably VLMs, are not very good at that. And so I'm wondering, kind of like, do you think those might be failure modes, or might there be others?
Yeah, thanks for the question. So I didn't present this here, but we are also looking at trying to figure out what is, when the model makes a commitment to a particular referent, trying to figure out which referent they are picking and whether there are patterns that check this. And at the moment, but this is, I think we still need to check it more systematically, but it does look that they have a bias for entities that are more in the center and in the foreground, which is not surprising. That would be perhaps a little bit human-like. So there are some biases. It's not clear that the models are systematic on this across models or within model choices as well. But I think definitely this is something that we need to look at. And sorry, what was the other side of your question? I forgot.
Oh, whether there might be some failure number reasoning that's coming from the uniqueness presupposition of the definite.
Right, but you mean whether there might.
I mean, I guess I'm thinking maybe the models don't know that the has this kind of uniqueness presupposition. I mean, it's a small word, classically stop word. These are kind of complex inferences. Numbers, they're not very good at those either.
Yeah, good point. Yeah, so I'm not sure. I don't think I can confidently respond to what is going on here, right? Very often they do respond with just a single answer. So it looks like the presupposition of uniqueness goes across, right? So that they are looking for one single referent. So that happens, and often when they describe what are the possible entities, they are also correct in the amount of entities that they give. So yeah, I think that these are still open things that we should look at in more detail. Thank you.
Super cool, thanks.
Thanks.
Were you saying something? So one last question.
Sure. Thank you for that great talk. My name is Ashish and I'm from Penn State. And I just had a question related to analyzing these models from the perspective of intent alignment. So you mentioned that these models have certain biases which are propagated in the samples that they generate as a part of their evaluation. I just wanted to know if you had the, like, have you done analysis on understanding which type of biases are good and which type of biases are bad in terms of intent, and whether the requirement of like resolving those ambiguous ambiguous references are required for that particular situation and where they aren't, because in some cases even humans evaluate certain situations based on their biases, and some biases are good for like understanding that situation more effectively. So just wanted to understand from the perspective of intent alignment, was that something that you've considered?
Well, I think, sorry, just very briefly, I think that this would be possibly a long discussion, right? So I think that all the things that you're mentioning could be very relevant, whether we have looked into them, not in any sufficient detail for now, but I think that, yeah, these are just meaningful questions that pop up from this kind of research. So, yeah, important to see whether all biases have the same type of status and whether actually some biases we want to promote them, right? So I basically agree with you.
Thank you.